Right. Let us see the requirements for achieving effective semantic representation. What we are seeing, we are talking about semantics. In the previous class, we have seen two approaches to semantic parsing: deep semantic parsing, shallow semantic parsing. And deep semantic parsing is highly complex and it is not required in natural language processing. We will be adapting shallow semantic parsing, and it is general purpose, it is adaptable across different domains. In the second lecture, we have seen the semantic theory proposed by Cods and Fodder, based on the grammatical generative grammars approach, and four properties of semantic theory. Number one, it should explain the sentence ambiguity. Number two, it should resolve the ambiguity based on the context. Number three, sometimes sentences may be syntactically correct but semantically no meaning. It should identify that. Number four, sometimes paraphrasing will lead to redundation and they may convey the same meaning. So it should be able to identify that. Then moving further, to achieve semantic representation, what shall be done? The first one, structural ambiguity should be resolved. So we are talking more and more in NLP about when we say structure. Structure means we're talking about syntactical structure. So when we have syntactical structure, there may be ambiguity in the structure. So understanding this ambiguity is very important in semantic parsing or semantic interpretation. For example, take the sentence: visiting relatives can be annoying. So this is very plain sentence, but the visiting relatives, is it a noun phrase, or actually when we visit relatives, that means visiting is a verb. So the ambiguity is whether visiting is considered as a noun together with relatives, visiting relatives, or visiting is a verb. So that is an ambiguity. So our semantic interpretation should resolve this ambiguity based on the context. That is the first requirement for achieving semantic representation. Number two, we have words giving different meaning in different contexts. Better we know that there are two types of ambiguities here. One phenomena is known as polysemy, where words with same spelling, same pronunciation, they represent different meaning in different contexts, but at the same time, those meanings are related to each other. That is known as polysemy. Then there is another phenomena called homonymy, where same spelling, same word, but not related meanings. They are different meanings. They are different. They don't have any relation in between. For example, you see here a body part, nail. Nail represents to our fingernail or toenail, or similarly a small metal object. We use it for fastening any chart or anything. That is the object. So if you see the context, for example, I have a sentence: he nailed the loose arm of a chair with a hammer. So when we use the hammer, we're talking about a metal nail. So based on this context, the word sense should be understood clearly. That means we call this phenomena as word sense disambiguation, which is very, very important in semantic parsing part of natural language, or other words, semantic interpretation. For example, if I say he bought a box of nails from hardware, the hardware store box represents two metal nails again. He went to the beauty salon to get his nails clipped. But when we talk about beauty salon clipping, then he's talking about fingernails. He went to get a manicure, his nails had grown very long. Nail growing, manicure, this represents two fingernails. So word sense disambiguation. It is an important property in the semantic interpretation. The first one, structural ambiguity. Number two, word sense disambiguation. So this process of determining the correct meaning of a word based on the context. That phenomena is word sense disambiguation, which is very, very important in semantic interpretation. So context means neighboring words or the topic of discourse that will give the context. So as we human beings, we understand this word sense disambiguation very accurately than a machine. But machine is not as capable as the human in case of this word sense disambiguation. So first requirement, ambiguity, structural ambiguity resolution. Not ambiguity is not requirement, but structural ambiguity resolution. Number two, word sense disambiguation. Number three, entity and event resolution. Which entity is being referred? Sometimes, for example, the ambiguity here is we may say Barack Obama or the former US president or Obama. They all refer to the same entity. You can say superstar, you can say Prince Mahesh Babu or Mahesh. All those refers to same person, a Tollywood hero. So this is entity. Similarly, event. Sometimes I may say COVID-19 pandemic and the global health crisis. Most these two are referring to the same event. So this resolution, which event, which entity is being referred, understanding that is very, very crucial for semantic representation. So named entity, there are two major tasks here in resolving this. One is known as named entity recognition. Whenever a name or noun is there, recognizing which type of entity is that. For example, whether it is a currency, whether it is an organization, whether it is a date, or whether it is a weight, whether it is a location, identifying the entity. Here, Apple organization is not eating apple. Eiffel Tower location, January 1, that is a date. This is named entity recognition. The second one in this, the second task is that co-reference resolution. Co-reference. So this will help us to understand which entity is being referred. For example, I say Elon Musk founded SpaceX. He also started Tesla. When we say he, it is referring to Elon Musk. So these two are very, very important tasks in entity and event resolution. Number one, structural ambiguity resolution. Number two, word sense disambiguation. Number three, event and entity and event recognition. Number four, predicate argument structure. So this is we'll be spending more amount of time dealing with this in the later classes. So predicate argument structure is dividing the given input into predicate and other arguments depending on it. So this is simply like when we are given with a sentence, who did what has been done, to whom it has been done, when, where, why, how of that event. This is known as predicate. And we have to analyze this predicate argument structure for better semantic representation. If you see here, the sentence is Bell Atlantic Corporation said it will acquire one of Control Data Corporation's computer maintenance business. So here, by analyzing this sentence, who said? Bell Atlantic Corporation said when, where, who it will, what it will do, acquire. What it will acquire, Control Data Corporation's computers maintenance business. When, whom, how. This is known as predicate argument structure. Another sentence, John gave Mary a book at the library yesterday. So the predicate is the verb, the action, gave. When what are the arguments? Who? John, subject, book, object, the thing given, Mary, indirect object, the receiver, to whom, and where, the library, when, yesterday. So this type of analysis is known as predicate argument structure analysis. This is very much useful in semantic parsing. And now lastly, meaning representation. This is the final step in semantic. Representing the meaning in a format such that it is manipulated, used by the computer. So there are two types of representations: deep representation, shallow representation. Deep representation is domain specific, highly complex, in detailed, in-depth relationships, analyzing, capturing deeper relations, logical structures that we called as deep semantic parsing. The second one is shallow, which is generalized approach. So these five are the important requirements for a semantic representation.